Alrighty, good afternoon, everyone. Thank you very much for coming to Ignite. I hope you all had a very fabulous week here with us in Atlanta. So many of us may have the flight delays in our life. Flight delay not only cause an unpleasant experience for our customer, it could be also very expensive for the airline companies. So the companies lose credibility when the flight cannot take off on time. It may also worsen that. The customers may also go to the competitors, who is now 1 mouse click away. So hello, my name is Catherine Zhao. I'm here today to share with you how we can handle this predictive maintenance scenarios using the Cortana Intelligence Suite. And I am a data scientist from Microsoft. So let me just switch the microphone a little bit. So there's a lot of offering in terms of advanced analytics from Microsoft. To simplify it down at the highest level, there are really two main offers. So we offer the advanced analytics in the cloud, including the Cortana Intelligence Suite. And the second one is the advanced analytics on premises through the SQL Server 16R services. So right now, there's a lot of cool things that you can do with the SQL Server R services. Now, I'm not going to touch that much today. So for today's talk, instead, I'll be mainly focusing on how to build the end-to-end and advanced analytics solutions using the Cortana Intelligence Suite. So let's say you're in the aerospace industry. If you want to predict which aircraft engine components are likely to fail next, Cortana Intelligence Suite can do that for you. Let's say if you are in the manufacturing industry, if you want to predict what is the root cause for your test failure, Cortana Intelligence Suite can do that for you. Let's say if you are in the transportation industry, you're interested to know whether you should change the car brakes right now or you should wait for another month. Cortana Intelligence Suite can also help you with that situation. All of us here are in a business where solving predictive maintenance use case could save us money, headaches, legal actions, all sorts of things. So that is what we want to accomplish today with the Cortana Intelligence Suite. Now you probably have this question in your mind. What is Cortana Intelligence Suite, right? So it is actually a suite of services. What we really want to do is we want to take the data all the way to the actions. So there's a lot of components within this suite, a lot of ways that you can use the different components to build up an end-to-end solution. So in today's talk, I'll be showing you some demos around how we can actually use those components in real life to build an end-to-end solution. Usually, there's no one right way to do this sort of things. It really depends on the use case, the data that you have, how you want the pipeline to flow, how frequent you want to make predictions. So let's say we take the data from different data sources. And we have a lot of services for the information management, such as the Agile Data Factory, can help us to orchestrate and move data around. The Agile Data Catalog is a catalog allows us to look into the metadata. The Agile Event Hub is an event hub that we use for the event ingestion. We also offer several big data stores, such as the Agile Data Store and the Agile Data SQL warehouses. In terms of the machine learning and the analytics, Agile Machine Learning gives you a very nice way to operationalize your machine learning model, and it also can help you to create web services in the cloud. The Agile HD Insight is another great way to do the scalable data science in the cloud, where you will have the Hadoop and the Spark cluster for it. The Agile Streaming Analytics allows us to do the real-time data streaming in 24/7. And we also can have a lot of ways that you can take actions on those insights that you just built or any of the predictions you come out of the machine learning models, such as Power BI you can use for the visualization and reporting purpose. We have Cortana for personal digital assistant. Bot framework can help you with the perceptual intelligence, and we can also do a lot of business scenarios in this case. So this is the agenda that I'm going to cover today. So I'll be talking through the predictive maintenance. So predictive maintenance can mean a lot of different things. So there's a lot of different use cases, concepts come within the scope. So I'll be talking through some of the typical predictive maintenance use case. Then I'll be doing 2 demos around how to build end-to-end solutions using Cortana Intelligence Suite. This including 1 demo to deliver a real-time and predictive insights. The second demo will be an end-to-end deployment with a Cortana Intelligence solution that has a one-click button to deploy. It's very simple. And lastly, I will cover how the machine learning can help your businesses with your different use cases. So we have some extra time today in this session, so feel free to stop me if any terminology or any knowledge blocks your understanding. I'm more than happy to help you straighten that out. So predictive maintenance, so what is that? Predictive maintenance is really maintaining based on the data. This concept has been around for a really long time. But if you might know, it has been actually changed a lot with the introduction of Internet of Things and more sensor data. So now we can use a lot of sensor data to predict the machine health. So traditionally, the predictive maintenance, we have a very little time variance information. So basically, we have a very little data with a timestamp associated with it. And we have a lot of data on the parts level, and we could be more model-driven at that time. But today, with more sensor data comes in, we can be more data-driven. We can really use that data to understand and even predict ahead of time. What we can do is like failure predictions, fault detections, or even looking ahead of time to see what is coming up next. So next, I will show you a quick demo for the aircraft engine. So this demo is really to show you how we can use a bunch of different components from the Cortana Intelligence Suite. So how we can actually, it just gives you a sense how we can stitch all those components together to build up a solution and how they actually work. So now let's step into the demo part. So here is our scenario. Imagine we have a guy named Kyle. Kyle manages a team that maintains aircraft. And he has 100 aircraft under his watch. And he wants to prevent flight delays due to the mechanical issue so that his customer will be happy. Unfortunately, engines occasionally show signs of failures and has to be taken off for maintenance or services, or even for replacement. So he has to figure out which engines need to do the maintenance next in order to minimize the delay. But he doesn't want it to do on the time schedule. He wants to use all those great information he collected from the sensors to do this proactively. So now I will switch back to my demo laptop to show you how he actually can use the Cortana Intelligence Suite in this case. So Cortana Intelligence Suite can use in many different ways here. We can look at how long each engine are sending the data, how much data is sending into the into the dashboards by looking at the historical information. We can also look at the current information to see any of the alerts are coming from the sensors, which we can do a real-time alerting scenario. We can also do even looking ahead of time, use the machine learning model to predict what kind of failures or when will our machine has a failures next. So this is basically the Power BI dashboard we built on top of the Cortana Intelligence Suite, the different components that we build this end-to-end pipeline underneath. So this is basically give you an overview of how people like Kyle would look at this dashboard and try to take actions on it. So we have some visualization updated in real time on this dashboard when the latest data comes in. For example, we can look at the fleet summary here. So this summary is an interactive visualization. We can click on one of the components here, which will bring us to the detail level of the predicted fleet health. So on this dashboard, it basically shows you all those aircraft engines that under Kyle's watch, what are the status for them. So as you can easily notice here, some of the aircraft engines are highlighted in red, which means they are right now in the severe condition and need to be taken out for a service. And if we click on one of the components here, you will see a lot of information has associated with this aircraft that can help Kyle to understand and better manage the next maintenance. So he will see some anomalies here, and he will see some maintenance information that help him to manage what's the next action items. And we can also see the machine learning model forecast from the machine learning model that we built in the pipeline. We can also see where this current aircraft is. It is actually in the London airport for this particular aircraft. Underneath, we have this flight schedules. So this flight schedule can help Kyle understand where the flights are right now and what is the next takeoff. And he can better manage the maintenance at where the parts are available. So going back here, we can also see a lot of information about alerts. So the aircraft are sending data and how many aircraft arrive at a certain airports here. So we built a monitoring system underneath. So this is a real-time monitoring for the sensor values. So from here, we have the data feeding every second for this sensor number 12. And we can see the data has been feeding here, and we have a predefined threshold for the alerts, which the value is 524. So in this case, it can help Kyle to understand, okay, so at certain points, as you can see, the graph is actually moving. So at certain points, the sensor value is go beyond this threshold, which will be considered as alerts, also showing up on this Power BI dashboards. At the bottom part of this visualization, this is where we will call out the machine learning models to let the Kyle proactively figure out how many remaining useful life has left on each of the aircraft engine. So what is remaining useful life? Remaining useful life is basically how many cycles has left on each of the aircraft. So you can think about the cycles is like the flight. So this is where Kyle will come in and see, okay, let's go down, those aircraft looks good. And when he go down and reach a certain point, like the number 36 here, you can see this particular aircraft has only 13 cycles left. So basically, we consider any number of remaining useful life below 25 as a critical condition. So that's where Kyle will come in and tell his team to say, okay, this aircraft engine 36 looks like we need to schedule a maintenance. We need to check on the parts availability so that we can do the maintenance at where the parts are available. And we can also see other good information from this dashboard, such as the engine diagnosis summary. So for people like Kyle, he might understand where all those components are on the aircraft. But for some people are may not very familiar with the aircraft engine like me, I can even look at this visualization and help me understand where all those faults are actually occurring. So we can see on this dashboard on the right-hand side, you will see the different number of faults that occurred at the different components on those aircraft engine. So it looks like the top one is on the cone. It has 65 faults in the past 6 hours. So if I don't know where this particular components are, if I just click on that, it will just show me it is actually this physical components right above the fan. So I think this is actually pretty cool. So as I have already shown you the different components that I used for building this aircraft, the Power BI dashboard. This Power BI dashboard basically gives you a 360 views about what is happening and what will be happening in the future. And now let's step into the second demo. I really want to show you is how we use the raw data coming from the different sensors and go through all the different data pipelines, and eventually we reach to this dashboard. So now I will switch back to the slides a little bit. I just want to show you what is coming up next. So the second demo is basically using the Cortana intelligence solution. So Cortana intelligence solution is a set of the pre-configured solution that can help you jump start with your advanced analytics. It will provision all the different components on the pipeline under your own subscription. It also helps you to discover and deploy just in a minute from the Cortana Intelligent Gallery, which I will show you a little bit. And also, as a customer, you're probably wondering how we can actually use it for our own use cases. You can definitely customize it. We provide the source codes, and I will show you where to find those source code. And you can also work with partners on those customizations. So now I'm going to show you the architecture pipelines for building this, the aircraft engine demo that I just showed you. So what we actually do is we took the public available data set from NASA. NASA published an aircraft engine runs to failure data. So we use this public data set and build a machine learning models to predict what is the remaining useful life on those aircraft engine. We look at the relationship between the sensor information and also those failure information. So since this is around to failure data, so we can actually infer that when the failure happens is actually when the machine stops working. This is actually the most ideal situations here. But in the reality, in a lot of cases, we don't have that fortune with our customer data. So I'll also be talking through how you can deal with this practical issues in real life. And we simulate this data like the data was streaming 24/7. Not like something one row per engine. We use the Agile Event Hub to ingest the data. So basically having the data streaming 24/7. And the next components that we use is the streaming analytics. So the streaming analytics that basically does two jobs. So the first job is for the real-time alerting scenario that I show you on the dashboard. It basically directly feeds the raw data into the Power BI with a certain level of aggregation. And the second one is to move the data to the blob storage. This is where the Agile Data Factory will be used to operationalize of moving data around, doing feature engineering, carrying out the machine learning models APIs, which the batch execution. Later, Power BI dashboard will also rate the updates from those SQL data warehouses, and to get the latest predictions on how much time it has left on each of the aircraft engines. So now I will switch back to the demo machine and show you what exactly has been built. So this is Cortana Intelligent Gallery. This is where you will find all those pre-configured solutions that you can just simply deploy it by clicking on the button here. So if you go to the solutions under the Cortana Intelligent Suite, you will see many of the pre-configured solutions here. And you will see if you click on all, then you will see all those solutions in the different scenario, different use cases. So the one I am going to show you today, which is also the one we use to build the dashboard, is this one, the predictive maintenance for the aerospace. So I give you a very nice subscription summaries about what this solution is about and what kind of scenario is actually solving the problem. And what we want to do is we just simply click on the deploy button. It will bring you to the Cortana Intelligence Solution panel, which is basically look like this. So as you can see, it has three different steps. So the only things you want to do is to enter a deployment name. So what we can do is we can do a predictive maintenance. Today is September 30th. So I just do use that as a deployment name. And you can choose the different subscriptions that you have. This is basically the Agile subscription. And you can choose the locations where you want all those pipelines to be deployed. And you can give a description, which is optional in this case. So once you enter this deployment name, oops, let me just refresh that real quick. So I'll do that one more time. So after we click on this create, it will start provisioning automatically all those different components into one resource group. So as you can see there's different stages are doing the different data movements, feature engineering, the machine learning models, and getting the result back to the SQL data warehouses. So those whole provisioning for this particular solution will take about 20 minutes. So we will not wait here today for this 20 minutes, just wasting of your time. So I already pre-deployed one from earlier this week. So it's called the PM4 Ignite. So as you can see, after all those components has been provisioned into your subscription, you will get some instruction about how you can monitor the pipeline, whether the web jobs has been finished successfully, and what is the Agile Data Factory components has been built. If you want to look at the SQL databases, then you have the identifications here. And you can also check on the machine learning web services in the cloud. And here is the part I really want to emphasize is the source code. So this is the source code that we provided to all of our customers. So if you are having exactly the use case, then you can definitely just use the solution, hook up your source data with the Event Hub to ingest the data comes in, and then it will hydrate the pipeline directly for you. But if you have a similar use case, but not exactly the same, you want to twist it around, this is how you do it. So you basically can download the web jobs here for all the source code. You can customize it. You can deploy it by yourself. And then you have this end-to-end solution basically in your pocket. And we also provide the technical guidance about how you can actually customize on every single step of this solution pipeline. So as we already have this solution deployed, I'll show you what you are having under the resource group. So if you click on this resource group, it will bring you to our Microsoft Agile portal. So this is where you will find out what kind of components has been configured into the subscription and how their status is and what kind of information and source code that we use in each of the components. So now let's dive into it. As you can see, we have, as I showed you on the pipeline earlier, we have the data factory, event hub, machine learning, SQL Server databases, and etc. So we'll dive into some of the components with more details. So the first components that I want to cover here is the stream analytics. So stream analytics, we have two jobs, if you can recall from the pipeline. So the first stream analytics job is basically feed the data directly into the Power BI. So this is basically how you are going to use it. So you just write a very simple SQL-like query in this panel that you can do a lot of cases. So in this case, I want to do the real-time alerting scenario. So I want to see, okay, I have a pre-defined threshold for the sensor 11 at the 48.26 value. And I want to see how many alerts I got in the past few hours. So that's just how simple you can build it up. And what you want to do is you just tell the stream analytics what is the input, which is an event hub source in this case, and what is the output. So output here in the Power BI dashboard, it gave you the 3 different tables. Basically, the 3 different tables will have different aggregations on it. So that's the first stream analytics job. So second one is the one that we move data from the event hub to the blob storage. And this one is very similar, but even more straightforward. So this one, we want to move all the data over. So what we want to do is just simply select star from the event hub source into the blob storage table. And that's it. That's all you need for the stream analytics. So next layer I'm going to show you is the Agile Data Factory. So this is where you can set up all the pipelines for the data orchestration and to move data around, and doing the feature engineering on Hadoop, and even doing the machine learning, to call the machine learning web services API with the batch execution. So there's a diagram here. So basically, this diagram shows you we have the raw data from the blob storage. And we're doing the first aggregation in the HD inside using the Hadoop cluster. And then we store the table in the blob storage again. Then the next thing we want to do is we want to call the machine learning web services API to get the scoring result on this new data set. And then after we have the score results, we will just copy the result over to the SQL data warehouses and then later on will be used in the Power BI dashboard. So the interesting one I want to show you here is the machine learning scoring pipeline. So if we double click on this pipeline, you will see the pipeline source. So here you will find all the source code that we actually define this pipeline in the Agile Data Factory. So as you can see here, this one, you just get a very simple JSON-like queries here. And what you want to define is how you actually want the data to move. So as you can see, we have a few pipelines here. So the one we're using for calling out the machine learning model is called the Agile ML batch scoring. So it's basically doing things like, I want to get the prediction out every 3 hours. And I am using Agile machine learning experiments, which is being defined as a link service here. So if I come over to the link service, so link service is basically where you hook up with the different components, and you predefined each of the components as a service here, and then you build this pipeline. So if I come over to this endpoint, and you will see this is how simple we can do for getting the prediction results back from the web services API. The only two things you will need is the machine learning endpoint here, and also API key. And these two pieces of information you can easily find in the Agile machine learning, which I am going to show you next. Any questions so far? Good. So the next one I want to show you, so next components on the pipeline is the Agile machine learning. So Agile machine learning studio gives you a very nice way to design your machine learning models. It could need some coding here if you want to design the data munging, feature engineering, and even the model all by yourself using R or Python. It could also be doing everything from just this canvas by drag and drop all those different components onto the canvas. So basically, as you can see on the left-hand side here, it have some like saved data sets. It have the data transformation that you have done in the past. So there's other components such as the data transformation modules, which it helps you to transform the data into the format that you need. And you can also, we have a lot of pre-built machine learning models that you can use for anomaly detections, classifications, clustering, and even regression models. So for this, we also include the deep learning models here as well. So if you are interested in trying out. So for this predictive maintenance, I will talk a little bit more about the data sets and also the different components that we use on this canvas. So let me zoom in here a little bit just to show you how it looks like. So basically on the Agile machine learning, we have the historical information from NASA. So NASA gave us 3 pieces of information: the raw training data, test data, and the ground truth data. So let me just quickly show you how the raw data looks like so you get a sense what kind of data that you're actually playing with. So we have the aircraft engine ID, we have the cycles here, and we have 3 operational settings. And also we have 21 sensor values. So this is all the data set we have for this experiment. This is the data that we use to define the machine learning models. As you can see here, we use a different R script to do the data munging and create the outcomes. As you can see, in that particular data set, we don't really have outcomes here. Usually, we will learn the relationship between our sensor values and also the outcomes. However, we don't have the outcome in this case. So this is like one of the typical machine learning problems that we need to solve. So it's to create the outcomes. So how do we create the outcomes? Since this is a historical data, that we know that the machine will be filled at the last point of time. So that's where we use this cycle information and to find out at which point of time this aircraft engine failed. And then we use that last point of time to subtract the current cycles. That's basically how we get the outcomes. So we use the R script to do those kind of data munging and normalization. So I just want to show you how the data looks like at the end before we try the different machine learning models. So as you can see, we create several different features here, which I will talk about a little bit more in which features we generated here. And the one I want to point out is this remaining useful life. So basically, this is the value of our outcomes. And this is where we use the cycle information for each of the aircraft engine to generate this. And the next, once we have the data that we are transfer and satisfied, we want to try the different machine learning models. So in the Agile machine learning, you have this very simple pipeline to do this sort of things. So you can just getting the data for the training data and test data. And you can, as you can see here, I'm trying 4 different models. I got the decision forest, boosted decision tree, and Partial regression, and the neural network regression model. So because we're trying to predict the remaining useful life, it is one of the regression use cases. So we can try different type of model, and we can even evaluate the model to find out which model performs better than the others on this particular data set. And once we are satisfied with our model, and we can just simply click on this Set Up Web Services button, and you will find the Predictive Web Services recommended. So that's the one you want to click on to convert this whole scoring pipelines into a web service that will be used in the Agile Data Factory that I showed you earlier. So I already clicked on that, and this already turned my whole scoring workflow into web services. As you can see here on this pipeline, we're adding a web service input. This is where you will connect to your data after the data transformation, or even before that. And this is the second components we add here is a web services output. This is basically where you will get your prediction results back. And for the 2 pieces of information I promised earlier, is for the machine learning web service endpoint, and also the API key. So once you have the web services deployed, you can click on the web services button here on this panel, and it will link you to this dashboard where you will find the API keys here. And once you click on the batch execution, you will find the endpoint for this web services. So you probably want to, this looks very simple to do it all by yourself, but it was actually a lot harder before the Agile machine learning hosts the web services and do all those things for you. So you don't have to write and rewrite any of the code to convert this whole scoring pipeline into a production. So you don't have to integrate it in. So Agile Machine Learning Studio gives you a very nice way to do all those things inside the one tool and one panel. So this simple interface can basically help you to take your web services to the production level. So now I want to switch back to my slides again. So to the conclusion, as I have shown you the 2 demos earlier, so we can see the Power BI can easily visualize the real-time and the predictive results for the businesses. The Internet of Things and the Stream Analytics connect the job directly from the source to the Power BI dashboard and consistently track the anomalies and asset performance. And Agile machine learning can capture the problem before it becomes a problem, and it streamlines operations without wasting our resources. And there's also other components that we use to stitch together to build up this end-to-end solution, which eventually make our Kyle a happy man. So the rest of the time, I would like to switch the gear a little bit to talk about how machine learning can help your businesses with the predictive maintenance use cases with some tips and tricks. So this could help you get ready with machine learning. What we all know is the better raw material, the better the products. So there's 5 criteria we always think about machine learning-based models with our customer. So the first thing is predictable. So the problem that we need to solve need to be naturally predictable in order to create this kind of workflow that I just showed you. So a lot of times the people with big data always say, let's do a data exploration. Let's try to find the good insights from here. That is great. But however, what we really need is like a sharp question. We want to know what we want to predict is which components or which engine are likely to fail in the next 5 days. Something like that. So the second one is for the identifier. You want to make sure that you have the data matters what you care about. You need to have the identifier at the level that you're trying to predict. So an example is that we work with customers which trying to predict the door failures on the train. So our customer have a lot of data about this particular case. They have a lot of train information, and we're trying to help them to predict which door is likely to fail. So it sounds like a very great use cases. However, if you think about it, and when we look at the data, and we notice that all the data sets that we got is actually on the train level, and we don't know what door those are related to each train. So you can think about how much of the noises that you introduced when you don't have the identifier at the level that you're trying to predict. So next thing is accuracy. So in the predictive maintenance use cases, we often have those failure information, and when did the machine fail, those kind of information are human writing. So we want to make sure that when human recorded those failures is actually when those failures happened in a time-based type of question. So the fourth piece of information is your data needs to be connected. This is the fact not having too much of the missing values in our case. So an example is that we work on the failure prediction. We usually have several months of data from the different pieces. But when we stitch the data together, we end up only have a few weeks. So then machine learning models basically training on a very few use cases, examples, may not perform very well in this case. And lastly is the size of data. We do need a lot of data for doing a predictive maintenance use case. The reason is for some of the failure, it is very rare. And you may just find a 1 or 2 example for it. So in that case, the machine learning model learning from a very small set of examples may end up not doing, predicting very well on the final results. So next, I want to talk about some of the data sources you can think about when doing the predictive maintenance use case. So first is the failure history, such as you can get the user information like when did the machine fail and what was the failure code. You can also consider the repair history. So the repair history, you can use what is the previous maintenance record, which components has been replaced. And we can use the machine conditions, which are those sensor information that we got up from those machines. And the machine features. So machine features is something like what is the production date and what is the technical specifications for those machines. And operating conditions. So the operating conditions you can consider such as the locations and the temperature where those machines are running on. The next one is operator attributes. So for example, if you want to predict the car brakes, the failure on the car brakes, you probably want to consider the driver's information as well in this case. And in the next couple of slides, I will talk about some of the machine learning techniques that can help you to build a machine learning solution. So feature engineering is a process of creating the features that can provide a better and additional predictive powers to a learning algorithm. So in our NASA case, we already have the information and the data points for every single aircraft for every second. In practice, we don't really need that much of granularity to create our machine learning models. So what we basically do is we extract those information and create a second layer on top. That is basically how we do for the feature engineering. So in this particular case, we're not only looking at the sensor value at a certain point of time, but we also look at the value like a rolling average. We look at how the sensor value it is comparing to its few periods before. So we use those techniques to create 40+ engineered features. And some other potential features that you can consider in a predictive maintenance use case will be velocity of the changes on the sensor value and the frequency counts over the predefined threshold. So for each sensor value, you can, based on the distribution, to predefine a threshold as considering as alerts. And then you can count the frequencies for those sensors and use that as one of your features for the machine learning model building. So there's some example methods to do the feature engineering, such as, like I said earlier, the rolling average to look at the mean over time. And we can create the different lag features. So not only looking at the value at this point of time, but also the sensor values, the 5 periods, or even longer before. All those different methods helps us to capture the degradation over time. So with the same set of data, the different machine learning model techniques can help you to answer different questions. So we can have a binary classification model to help you predict which aircraft engine are likely to, the aircraft engine is likely to fail or not. Those kind of questions in a future time frame. And for the regression model and the survival analysis, like in our NASA example, we use the regression model. And this is where we can answer questions such as, what is the remaining useful life? How many cycles does this engine have left before it has a failure? And we can also do the multi-class classification problem, such as if you want to predict what the different root cause for your failures, the multi-class classification model can do that for you. And lastly is anomaly detection. Anomaly detection models can help you identify the changes in the normal trend that be able to capture the anomalies. So this is the technique that I mentioned earlier, that usually we don't have the fortune with our customer data, that we don't really have the failure information, or we don't even have the outcomes to create our machine learning models. So in our NASA case, we have, this is basically the data that I showed you earlier. So in this example, that we know the aircraft engine 1 has in total 192 cycles. So because this is a historical run to failure data, that we know at the last point of time, which is 192, this engine failed. So in order to create the different labels, we use this information and subtract the current cycles to create the remaining useful life. So basically, as you can see, for the cycle 1, the remaining useful life will be 191. And so this will be the outcomes that we're going to use and learn the relationship between the outcomes and the different features that we created earlier. And the label 1 and 2 are for different use cases. So label 1 is help us to predict whether this engine will fail in the next 30 days or not. So in this case, instead of having those continuous values as in the remaining useful life, we label it the last 30 data points as ones. So you can see the last 30 are all ones, and any data points any previous data points will be marked as zeros. And label 2 are used for the multi-class classification model. So in this case, we basically have a different cutoffs. So we can see, we want to predict whether the machines are likely to fail in 15 days or is likely to fail in 30 days. So then we have zeros, 1, and 2 in our case. So this is, in general, this is the machine learning process where we will start from the very left-hand side by defining the objectives, understanding the data, and pre-processing it. So the pre-processing could take a very large effort in the different cases, especially when you have a very large data set. So what we usually suggest you to do is for the pre-processing, you can consider doing it on the Hadoop or Spark clusters. And after the data munching, then you can move the data to the Agile machine learning. So the Agile machine learning is basically doing the pipelines in the middle and the one on the right. So in the middle part, Agile machine learning can take the historical data and split the data into training and testing. So in predictive maintenance use cases, we usually suggest to split the data based on time because we have the time varied information. So let's see, we can take the first 9 months of data as training and the last 3 months of data to validate how our model performed. And once we have the trained model that we're satisfied, and we can easily convert it to the scoring workflow, which is on the right-hand side in blue. So this is where we can take the new data points and use the machine learning model we built in the Agile machine learning and get the prediction out. And in the Agile machine learning, and you can also create the web services for either the batch execution or the REST execution to get the results for the different cases. So I want to end this talk with a quote here before I have a few slides of the links for you to try out on your own. So most IoT data are not used currently. The data that are used today are mostly for anomaly detections and control, not for operationalization and prediction, which provide the greatest value. So I would see the predictions are very valuable use case with IoT data. We can do a lot of things with our sensor and machine data in this case. So solution templates I showed you earlier can help you to jumpstart into those kind of solutions. And you can also customize it for your own data sets. So here are some resources for you to learn and adapt before I open it up for other questions. So you can try out the Cortana intelligence solution, the predictive maintenance for aerospace templates, that you can use this advanced analytics with the different components in the cloud. You can also explore the predictive maintenance template. It is also available in Cortana Intelligence Gallery for the detailed explanation about the machine learning models that I explained to you earlier, which also including what kind of machine learning models you can consider to solve what kind of predictive maintenance use cases. And the third is you can read our predictive maintenance playbook for details of how to approaching those problems, how really you have a data set like this, and how you can think through defining your use cases, how you can actually take after you define the use cases, what kind of data you need to extract to be able to answer those use cases, and also the machine learning parts, that what kind of machine learning models that you can actually build for each use case. And lastly, if you are interested in doing all those solutions on premises, and we also build a predictive maintenance templates with SQL Server R services, where you will use our latest R technology called the Microsoft R server inside the SQL data warehouses, that you can use that solution for your on-premises solution. So with that, I will say thank you so much for coming to my session at the Friday afternoon. And if any questions I can help you with, that would be great. Mm-hmm.
So what's usually the general practice in telling if you've got a sensor that doesn't read from oil and that sort of thing?
Sure. So the question, I think this session is recorded, so I'll just repeat the question real quick. So the question is, we often have the sensor values which reading from the machines that has null values, right? So how we can handle this kind of problem. So what we usually do is depend on different cases. If some of the sensor value, like in my experience, if they're just majority of them are missing, then it's probably, I will look at the distribution of the sensor values and see whether there's certain information I can extract. If not, then I will probably exclude this particular variable from the data sets. So that's one way to do it. And if you only have a very small amount of data that is missing in your in your whole data set, then this feature can still be used. So what you probably want to do is for the missing value imputation, which is the way that you can use different techniques to impute those missing values based on other information. So some of the common techniques that you can consider is for a feature, and you can impute the missing values with like a mean, like a median, those kind of value. Or if it is a time-based information, so it basically has a time stamp associated with it, then you can think about whether you should consider the value of one period before or a few periods before, so let's say a week before, whether that kind of makes sense. If you can do a plot to see whether there's a relationship between your timestamps and also that feature value. And lastly, one technique I will also consider is for using other features in your data set to, if they are not missing in the mosel point, and then you can use that to predict. So treat this particular feature as your outcome, and then predict the missing values in this one. So there are different techniques that you can use in order to have a whole data set without the missing values. Mm-hmm. You're welcome. Any other question I can help?
I'll take another one.
Oh, sure.
Okay, so let's say you were trying to set up a prediction on event attendance, right?
Uh-huh.
And that's usually pretty dependent on weather.
Mm-hmm.
And so would you, if you were collecting your data, would you look at the weather at the event time, or would you look at, or would you maybe pick a period like a couple hours earlier? So you're taking, so let's say you take attendance data, right?
Mm-hmm.
And then you want to pick weather data. Well, weather data is collected other places, so you
Mm-hmm.
try to match the two data sets
Mm-hmm.
up. So if you're trying to predict what your attendance would be in the future of an event, sort of based on past attendance and also weather, would you pick the weather at the time of the event, or something maybe a little bit sooner?
So I will actually take those weather information. Actually, I will take several different features in this case. So I will look at the current weather, like you mentioned. I'll look at the weather. Remember the feature engineering techniques I just mentioned. Not only look at the sensor value at a certain point of time. In this case, will be the weather information at this certain point of time, but also maybe the 5 periods before, maybe 5 hours before, or even 12 hours before. So it depends on the case by case, right? You can also consider. So like see weather information, you can have not only the temperature. So for a certain, if you predict for the train failures or like locomotive failures, and you probably want to consider like the snow dips in the winter time, right? So those information you can consider using the accumulated data over time. So let's say if you have a 1 inch of snow at early morning, and then after a few hours, and it keep like snowing, and then at the end, then you probably end up having 6 inches of snow. But instead of looking at only 1 inch of snow at the last data points, you probably want to consider how accumulated over time the snow dips will be in this kind of case. So I would suggest to use the weather information, the different weather information, consider in your particular predictive maintenance case, what kind of information will make more sense that will have the most impact on your machine. And then even one temperature or one snow dips or those information, you can create several features and use those different features inside the machine learning model. And then the model, when you train the model, you will later on figure out which features will contribute more than the others to your whole, for this particular model.
So you talked about training, I guess you had 3 different scenarios, I think Markov, and then failure, 30 days, last cycle, or how many remaining lines, right? So through the application, does it show you the feature? How do you figure out which features when you run those different scenarios and you do the training, how does the machine learning in Microsoft provide, how does that, sorry, I'm looking at something.
No problem, go ahead.
How do you determine, once you've run your models and trained it, which features the different scenarios felt were most important? Is there like a weighted probability for each of the features?
So in the Agile machine learning, that the studio I just showed you, so at the beginning, you can look at the distribution of each feature. So basically, if you have some statistical knowledge, then you will probably get an understanding how the data actually looks like. And also, once you fit into the different models, so a different model will generate the different outputs. But in general, it will give you like a feature importance kind of score. So based on the score, you will understand what is the relationship between your features and your outcomes. So let's see, some weather features really have a high score. So the in common techniques, which I will usually take is I will select the first, let's say if you have 100 features, right? So you all fit into the model at the beginning, and then you don't really know much about it. So you can definitely do that. And then once you look at the feature importance score, then you can select the first 30 features. And then you build the same type of model, not the same model, it's just same type of model. Again, and then you can see what the first is see how your model performs. Does it perform better or perform worse? The second is you can see whether the feature importance score has changed or not. So because in some cases, some features internally has some correlations to each other. So using one or the other, or using these two together, will sometimes cause a different result for us. So that's the different way that you can twist around. And even for different models, there's a lot of hyperparameters, which is like the parameter you can adjust. For such as a logistic regression, you can use some regularization techniques to prevent overfitting. So that's some parameter you can adjust to get a better prediction result. All right, cool. Any other questions? All right, great. Thank you so much, and sticking at the end. I hope you all had a safe trip back home.
I only live 3 miles
Oh, okay, great. All right, thank you.